Welcome. We are going to solve yet another problem. And the figure at the screen will look familiar to you if you are following the previous year questions of JEE Advanced. You must have seen this picture before. But this is not the same problem. But I will describe the method to solve any kind of it. And the problem at the screen says two coaxial wheels with radii R1 and R2. You can find them. Rotate in the same direction with constant angular velocities omega 1 and omega 2. Omega 1 is greater than omega 2 and R2 is greater than R1, right? A third wheel with radius R3 equals R2 minus R1 by 2. This is good deal. Is clamped between the wheels and moves without slipping. That's right. Find the angular velocity omega of the third wheel. Okay, and that has been clamped between the wheels. Okay. And the velocity v0 of its center. These two are related. If we get omega, we can get v0 easily. And this is not slipping. Something got in my mind. Rest of the things are just data. And I can put data later. So the first and the second wheels rotate with angular velocities omega 1 and omega 2. That's right. They rotate, not translate. They rotate with angular velocities omega 1 and omega 2. So the velocity of point A. Why this point A and B are important to me, I don't know. Why I have drawn point A and B? I designated the points of contact of the third wheel with the first and the second wheels. Point of B, A and B are nothing. They are points of contact of the third wheel with the first and second. A is with the second and B with the first. Yeah, point of contact. So that means I think, tell me whether I'm right or wrong, the velocities of points A and B coincide with the velocities of points located on the rims of the corresponding wheels. A की velocity coincide करनी चाहिए बड़े वाले व्हील से और B की छोटे वाले व्हील से. So I can write velocity of A as omega 2r2 because it coincides with the bigger wheel, and velocity of B as omega 1r1. Yeah, this is my equation number 1. This is 2 because these are useful relations. And next, what do I need to find the angular velocity of this clamped wheel, third wheel? I don't know. Should I leave the problem? I think it will be convenient to use the concept of instantaneous axis of rotation. Instantaneous center of rotation. Where is the instantaneous center of rotation? Let's call it M. Why M? Why is it here? I don't know. I just assumed it. I can assume anywhere you want. but kindly make sure that their centers, make sure that the line you are taking as an instantaneous axis of rotation should be the line joining centers, line joining their centers of all the wheels. And on this line I can assume the instantaneous center of rotation anywhere, because I don't exactly know, I am not supposed to be God, so I don't exactly know the real position of instantaneous axis of rotation, so I can assume anywhere. I have assumed here. And this distance OM I assumed is what, x, or I assumed OX equals RX. Yeah, this, say मैंने मान लिया OM. Then with respect to this instantaneous center of rotation, I should write the velocity of point A, and if this distance is Rx, the distance BM should be R1 minus Rx, and this is 2R3. So velocity of VA can be written as, velocity of point A can be written as omega R1 minus Rx plus twice R3. This is my equation number 3. And what is the velocity of B in terms of instantaneous center of rotation? This is B. So this is R1 minus Rx plus B. B is quite simple, simply R1 minus Rx. So velocity of point B is omega R1 minus Rx. This is my equation number 4. अभी 4 इक्वेशन लेके मैं करूं क्या? What do I need to do next? Solve each of them simultaneously, and you are going to get your omega. It will be like this: omega 2 R2 minus omega 1 R1 divided by twice R3, and that should be your answer. What about omega V naught? How can you find V naught? V naught. V naught is omega, you got, multiplied by, find the distance of this position, center of the third wheel from O, and this is R1. No. Instantaneous center of rotation is here, so this is R1 minus Rx plus R3. R1 minus Rx plus R3. Before finding omega, you are going to find Rx, because R1, R2, R3 you know, and BB, yeah, I can find omega 1, omega 2 relation between, yeah, okay, I can find all of them. So this is also, this is not an unknown, this is not an unknown, because these two things are known, Rx and omega. Yeah, you can find it. Thank you very much for watching. Please remember the instantaneous center of rotation. This is very useful in relating velocities. Thank you very much again.